In this video, we'll take a look at dividing polynomials, both dividing a polynomial by a monomial as well as dividing by a binomial. To divide a polynomial by a monomial, we are dividing each term in the numerator by the term in the denominator. We also want to remember our quotient rule of exponents. We subtract the exponents when we're dividing. And I also have a note on here to always factor out the GCF prior to using any of our dividing methods. So we're going to start with our first example. It says 8n squared minus 36n divided by 4n. We're going to go ahead and divide the coefficients for each term. So it's almost like we're setting up two separate math problems. 8n squared divided by 4n squared. 8 divided by 4 is 2. N squared divided by n, we subtract the exponents and we're left with an n. And now we're going to go on and divide the second part of our binomial, negative 36n by 4n. Negative 36 divided by 4 is a negative 9. And our n's would cancel each other out when we subtract those exponents. And our answer to this division problem is 2n minus 9. Let's take a look at example B. I've got negative 14x to the 12th, y to the 5th, and we're going to divide it by 7, x squared, y squared. We divide the coefficients, negative 2. We subtract the exponents, x to the 10th, y to the 5th, subtracting y second. 5 minus 2 gives us y to the 3rd power. And we move on to the second binomial. It's positive. I need a plus sign. 7 divided by 7 is 1. X squared, y squared, they cancel out, and we're left with just 1. So this is our final answer. Take a moment to pause the video and practice your dividing. Divide the coefficients, but subtract the exponents. Take a look at the answers that are provided for A through G. Keep in mind that you can also check your answer. If you're getting 2x plus 3, I could multiply it by the denominator. So I'll be doing some distribution here. 3 times 2x is 6x. 3 times 3 is 9. I should be getting back the numerator as I multiply my answer times the denominator. So you can self-check that way as well. And take a look at our last two examples as well. As we take a look at the next part, we're taking a polynomial and dividing it by a binomial. We can use the factoring methods to divide a polynomial by a binomial. So keep in mind that if there is a greatest common factor in the top, in the numerator, we'd want to take that out and then factor. In this case, I do not have a GCF, but it is a trinomial, and we learned that we can use an X box to help us factor. I put the last number in the top for multiplication. The middle term coefficient goes in the bottom for addition. I'm looking for two numbers that multiply to negative 8, but would add to a positive 7. 1 times 8. I need the 1 to be negative. We learned in our last portion on factoring that we can rewrite these side pieces as our terms, x minus 1 and x plus 8. Those are our factors. And when I take a look, I can see that I have a common factor in the numerator and the denominator. So x minus 1 divided by x minus 1 is 1. and I can't do anything else. So my final answer is the x plus 8. It's the factor that remains once I cancel them out. I'm just left with x plus 1. I'm sorry, x plus 8. Let's try the next example together. I have x squared minus 10x plus 21. I look for a greatest common factor, which I don't have. I'm going to put my 21 in the top and my negative 10 in the bottom. Think 3 and 7. They both will have to be negative in order to add up to negative 10, but multiplied to 21. I'm going to rewrite that as x minus 3 and x minus 7. And on the bottom, I have x minus 7. X minus 7 is my common polynomial, so I'll factor that out. And we're left with x minus 3. And this is my final answer. And just like on the front side, I can take that x minus 3, maybe I'll put that up here, x minus 3, and multiply it by the denominator, x minus 7. And I'll do some double distribution. Which we practiced in a previous unit. And we'll combine our like terms. And we should get what we started with in the numerator. As we take our answer and multiply it by the denominator, we should get back that original numerator. Letter B looks a little different. It's just written out as a trinomial divided by a binomial. So if you want to, you can rewrite it to look like a fraction, like we've been seeing on our other examples. I'm going to take a look at my x box. I'm going to put negative 33 in the top and 8 in the bottom. My factors of negative 33 would be 1 and 33, or negative 1 and 33, but also 3 and 11, where the 3 would be negative, 11 would be positive, and that would add up to a positive 8. My factors on the top are c minus 3 and c plus 11. My denominator was c minus 3, which is the polynomial that they have in common. So we'll cross that out, and we're left with c plus 11 as our final answer. Letter C is y squared minus 25. You may recall this is the difference of perfect squares. So when we factor this, it becomes y plus 5, but also y minus 5. If you're not remembering that sum difference pattern, you could rewrite this as a trinomial with 0 y's in the center, minus 25. And then jump to your x box, and you're looking for two numbers that multiply to negative 25 but add up to 0. That's where my opposite, negative 5 and positive 5, come in to give me these two factors. I can cross out the common factor, and we're left with y minus 5 as our final answer. Go ahead and pause the video and try D, E, and F, and then check your answers. Okay, take a look at the next row, D, E, and F. For D, we just had a greatest common factor of 4m that we moved out of the front, and we were left with m minus 5. That became our common polynomial, so we removed that, and we're left with 4m. On letter E, I did not have a GCF to take out. So this is that type 5 factoring that we learned last class, where we multiply the first and the last term together to go in the top of our x box. 5 goes in the bottom. We're looking for two numbers that multiply to negative 24 but would add up to 5. And now we do factor by grouping. So we're taking the middle term of 5n and splitting it up between these side pieces. Negative 3n plus 8n minus 12. And we slice it in half. We take the GCF out of the first half and write our leftover factor. We take the GCF out of the back half and our common factor. This is what they share in common. We rewrite it as 2n minus 3 and then n plus 4. The 2n minus 3 is that factor they have in common. We'll take it out, and we're left with n plus 4. On letter F, our GCF here is 2. So I took that out right away and then wrote my trinomial, put negative 35 in the top, negative 2 in the bottom. 5 and negative 7 will work for that. So I've got 2 from that GCF, d plus 5, d minus 7. The d plus 5 is what we can divide evenly, and we're left with 2 times d minus 7. Our application problem has a rectangle with an area of 12m squared minus 7m minus 10. If the width of the rectangle is 3m plus 2, write an expression to represent the length of the rectangle in simplest form. So remember, area of a rectangle can be found by doing length times width. Well, they gave us the width right here, and they gave us the completed full area there. So if we already have the area and we have the width and we want to find the length, we're going to divide the full area of 12m squared minus 7m minus 10 by 3m plus 2. So this is a dividing polynomial application. I don't have a greatest common factor, so I'm going to have to multiply the first and the last term together to get negative 120. That's going to go in the top of my x box, and I'm looking for it to multiply to negative 7. So I can start listing my factors of 120 or negative 120. So I have 1 and 120, 2 and 60, 3 and 40, 4 with 30. Okay, I need to get a combination that would combine to be negative 7. So let's see, 5 and 24. 6 and 20. 7 I don't think works. Let's see, 120 divided by 8. Would that work? So we want to keep testing out to see if we can find our factors and see what we can come up with. So 120 divided by 8 gives me 15. So 8 and 15. If I work with 8 and 15, I think we're going to get some sort of negative 7 there if I make the negative 15 or the 15 negative. So just double check. 8 times 15, negative 15 is negative 120. When I add that, I get negative 7. So now I have my two factors on the side. That is the breakup of this middle one. So I'm going to rewrite it as 12m squared plus 8m minus 15m minus 10. So I can do my factor by grouping, which means I split my 4 terms and take the GCF out of the first portion. And I take the GCF out of the back portion. Then I can rewrite my common polynomial and my pieces as my second polynomial, all being divided by 3m plus 2, which is the goal. We want to have a factor that is in common with the denominator. So as we complete the dividing portion, this cancels out, and we're left with our length equaling 4m minus 5.